Good evening, everyone. I'm not going to lie, this is quite intimidating. The last time I spoke at Cardiff-JS, there was maybe like 20, 25 people max. So it's really cool to see so many of you have turned up. Like I said, a little bit intimidating. Might have to bear with me in some places, but welcome to all of you. So yeah, we'll kind of just jump straight into it. A couple of disclaimers to begin with. Standard one, kind of views expressed to my own. A lot of you will know I work for Oodle. I'm not trying to discredit British Airways with this talk, so don't take it like that. I've never worked for British Airways, so that's kind of going to become important later on in the talk. The reason I've chosen this subject is because it's a really interesting data breach for us to kind of look at. As I presume most of the people in the room are kind of developers, or we're involved with kind of web development in some way, shape, or form, right? So the reason this is such an interesting topic is because we get to kind of see behind the curtain a little bit of how a data breach actually occurred, but we don't have kind of the full picture of it. If I work for BA, that might be slightly different, but I don't. And finally, I don't have security in my role. I'm a senior software developer, I suppose. So I'm going to give some very kind of generic advice at the end of it. I think it's good advice, and I've done my research on it, and it's stuff that we've been doing in-house as well. But yeah, if you have kind of legitimate security concerns about any kind of web properties that you're using, I would strongly advise you go and speak to someone who knows what they're doing. So we'll kind of jump straight into it then. So when I kind of say the word card skimming, I'm not sure about you, but for me, the first thing that kind of jumps to mind is this kind of thing. Does anyone else kind of, whenever they go put their card in the ATM, do they jiggle the little machine as well and make sure there's nothing coming off and that sort of thing? I do. I'm quite paranoid about that. But nowadays, actually, this is a way bigger threat for us as consumers. This is actually the booking page for British Airways, and it'll become kind of really the focus point of this entire event, really, that we're going to go through. So we'll start then on the 6th of September 2018, when British Airways announced publicly that they have suffered a fairly substantial data breach. So if you were an existing British Airways customer, you would have received an email kind of with a apology and directing you to the site for further information. And if you were to visit the site, you would have seen something like this. So I think most of us, if we've seen kind of any sort of data breach before, we've seen kind of a similar sort of shtick to this kind of thing. But there are a few things here that kind of stick out as being quite interesting. The first thing really is the fact that we have a really specific time frame within which this data breach occurred. So, okay, the whole sort of 9:45 BST, September 5th, when it ended, that makes sense, right? We've investigated the problem, we've patched the problem, we found a fix or whatever. That's the point at which we deployed it, and now our site is safe. The one that's a bit more interesting is the start time, because generally speaking, when you suffer a data breach, you don't know really the kind of to the minute when that actually started. If you're really lucky, you might kind of know maybe the week or sort of the day, perhaps. But typically, that's a harder thing to kind of pin down exactly when we became vulnerable and when we started leaking data. The next thing that stands out is that the breach affected both the website and their mobile app. That's kind of interesting, and we'll touch upon that as we kind of go on. And then finally, they kind of specified that the data that was lost didn't include travel or passport details. So if you were to visit that page and kind of scroll down, there's kind of a whole sort of accordion section of sort of FAQs and that sort of thing. And buried way down deep in that page is that names, billing addresses, email addresses, and all bank card details were all at risk. And when they say all bank card details, they mean everything, including the three digit code on the back of the card as well. So we know that we have a really specific time frame that this breach occurred in. We know that it affected the website and the mobile app. We know that all the card info, the billing address, names, emails, they were all breached as well. We know that there was no passport or travel details that were leaked. And they didn't specifically mention that they had had a server breach or a database breached. Okay, so these are kind of some interesting points that we'll kind of keep in mind going forward. And actually, these points are what kind of piqued the interest of a company in the States called RiskIQ. And on the 11th of September, they released a report into the findings that they found. So RiskIQ are a really interesting company. They're a security research company based in the States, as I said. And kind of what they do is they scan websites. They scan, I think, somewhere in the region of 2 billion pages a day. And they're indexing all of that data. So essentially what they have is their own kind of personal Wayback Machine where they're able to look at a snapshot of what a website was doing, what sites it was loading, what it looked like, what assets it was bringing in on particular days historically. And they released this report, and their head researcher, a guy called Jonathan Klinsmer, had this to say. He said, because these reports only cover customer data stolen directly from payment forms, we immediately suspected one group, MageCard. So a bit of a crash course into kind of who these lovely people are. They're effectively a group of hackers, okay? Their MO, the thing that like their bread and butter really is digital card scanning. They write these kind of bespoke scripts that they'll inject onto sites to scan card data. They initially, I think, started kind of with kind of Magento forms and Magento backends, I think, and that's kind of how they got their name, I think. And they're really not picky about how they get their malicious code onto your site. If they can breach your site directly, they'll do it that way. If it's easier for them to go and breach, say, a third-party CDN that you're pulling scripts in, they'll go and do that. I think that's the approach they took with Ticketmaster. That's kind of a more recent one. And as part of this investigation that RiskIQ were doing, what they found was that the booking page on British Airways was loading over 30 scripts, which is a lot. That's thousands of lines of code. And as an attacker that wants to hide some malicious script somewhere, that's like a dream come true. Like, I can hide that script somewhere, and it's going to be really difficult for you to trawl through all of that and actually find where I've put it. And what they found, well, as they were kind of going through this historical data for British Airways, this one script kind of jumped out to them. It was being pulled in from kind of an internal CDN for British Airways. So you land on the British Airways booking page. It tells the browser to go and load this particular script from British Airways CDN. The browser just goes off and does it, delivers it back to the page, and carries on running. And the reason this one stuck out for the guys at RiskIQ is because in the headers that were coming back with this script was this. It was the last modified date. And it was last modified on Tuesday, the 21st of August at 8:49 GMT. And of course, this rang alarm bells because that's suspiciously close to when we have this really specific start time for this breach. So, okay, we think we're kind of on the right track here. And what they found when they investigated this script was this. It's a bit of JavaScript. It's pretty simple. And effectively what it's doing is it's going to wait for the window to load. It's going to look for an element on that page called the submit button. It's going to bind against some of the events on there. So when certain events are fired against that button, it's going to execute some code. And the events that it's bound to are the mouse up and the touch end events. And then what it's going to do is it's basically going to go and find a payment form object in the HTML. It's going to go scrape all the data out of it, put it in another object. It's going to string it all up and send it off to this API. And this API is really quite interesting. They're serving it over HTTPS, which is odd because they didn't necessarily have to do that. However, the approach that they'd taken here was to try and hide this network traffic from BA as best they could. So you'll notice that they're also sending it to this baways.com domain. It's something that's obviously controlled by the attackers. And like I said, it's designed really to kind of blend in as best as possible with the rest of the stuff that's happening on that site. And this is kind of the crux of it, really, is they'd actually just skimmed all the data on that page before it had been encrypted. And this, for me, is really the important bit, because as consumers, we're often told that, hey, if you're visiting a website and you're going to the payment form, make sure you've got that green padlock in the corner, it's being served over HTTPS, and if you've got that, you're sorted, everything's fine. But actually, that's not the case here. The site's served over HTTPS, but because it's scraping that data as it's being put in onto the form, it hasn't had a chance to go and encrypt that data yet. It hasn't actually been sent off. So remember we talked about how the breach had affected both the main website and mobile. Well, the attackers thought of that as well. They bound to this touch end event. And this is quite clever on their part, I suppose. I can understand where British Airways have come from here, because what they've decided to do is they want this mobile app, and they want it to be really performant in certain parts. So when you're kind of searching for flights or you're searching for hotels, okay, we're going to make that part of our mobile app native, so we can make it really performant, really fast, and a good experience for the user. But for the rest of the site, actually, we don't care about performance that much, so we're just going to call off and just basically proxy the website. Which, okay, it's a good idea, but the problem is that they've also included the booking page there. And the attacker spotted this. It's a free win for them. I mean, the only extra bit that they needed to do was to bind to that separate touch end event. And suddenly the pool of people whose data they can take has just grown substantially. So we fast forward then to the 8th of July, 2019, and the ICO, the Information Commissioner's Office, come out with their announcement. Elizabeth Denham, the Information Commissioner, makes this statement really clear. The law is clear: when you are entrusted with personal data, you must look after it. And fundamentally, they found that British Airways hadn't looked after it. They handed them a £183.39 million fine, 1.5% of their 2017 global turnover, so it could have been a lot worse for BA. IAG, the parent company of BA, they saw a fairly substantial share valuation drop. It had actually been declining more than that as this whole saga had been going on, and British Airways weren't really saying very much to the media, they weren't really saying very much to their customers, and they were kind of seeing this hit in the market the longer and longer it dragged on for. But really, the number that matters the most, I think, is this one. 380,000 customers had their details stolen. And if you've ever had your card details stolen, it sucks. You need to go phone the bank. The bank needs to start doing their investigation. It's a whole kind of, it's a nightmare to go through. And whenever I kind of see these kind of things, I think about sort of, okay, how would I explain this to my grandparents, for instance? If they'd been affected by this, they wouldn't understand any of what's just happened. how do you explain to them that someone on the other side of the world has stolen their credit card and that now all their money is in danger of being taken from them? The ICO actually kind of bumped that number up. They kind of estimated it was more like 500,000 customers who had been affected by this breach. Kind of numbers vary there. And again, I think this is, for me, it's okay, fine, they've had this fine levied against them. And yes, they, as a company, British Airways kind of worked with the ICO to kind of get better and sort some of their issues out. But fundamentally, this is such an easily avoidable problem, and it never needed to happen in the first place. And so, what can we learn from their mistakes? I think, for me, this is what I like so much about kind of investigating these kind of things, is that it's much more fun when you're learning about security when you're learning from someone else's mistakes. If you're having to learn from your own mistakes, that's pretty rough. But learning from others is, yeah, it's definitely the best way to go. So, this is my attempt at being a front-end developer now. So, I'm sure some of you will recognize this is a kind of modified version of the Create React app. I've just stuck it up on Netlify, so it's somewhere that's hosted that I can go and start running security scans against. I think you'll agree I've done a pretty good job, if I do say so myself. Thank you. If you haven't seen Netlify before, it kind of looks a bit like this. Essentially, you give it access to one of your GitHub repositories. It'll grab that repository. You tell it how to run that code. It will try and do it. It will deploy it. It will give you a URL that you can visit your site at. And actually, one of the nice things it does is, because it's using Let's Encrypt, it gives you an SSL certificate right off the bat, so you get HTTPS for free. And the way this works is that, effectively, every time I'm a naughty boy and I push to master without PRing, it will just do a release for me. So, the tool I'm going to use then to kind of interrogate this site is it's a free tool, Mozilla Observatory. Has anyone here used this before, seen this before? Cool. I really recommend you go and give this a go. It takes a little bit of getting used to kind of figure out actually what it is you should be looking at, but hopefully we can work through some of that now. So, great, I've thrown my site up on the web, and I pointed the observatory tool at it and said, hey, go and do a scan. And it's come back with a D+, which is pretty good. I did worse than that on some modules in uni, so I'm okay with that. We're scoring 40 out of 100. That's okay. And we've passed 7 tests out of 11, so I'm right with that. These are all our test scores. And this is what I mean when I say that Observatory takes a little bit of getting used to. The first time I opened this up, I went, oh, cool. Ticks, crosses, minus scores, zeros, and the rest of it is just noise. But the first thing that we can kind of see here is that, okay, the thing that we're getting marked down on the most is this content security policy. Why are we getting marked down on it? Well, because we've not implemented it. And that's correct. I've literally just taken Create React app, build me a site, and stick it on the web. So that kind of makes sense. So, okay, what is it? If you follow the links on the Observatory tool, it will kind of link you to some documentation where you can kind of read up on it. I think for me, this is probably the bit where Observatory falls down. It tries to kind of hold your hand a little bit and kind of point you in the right direction. But a lot of this research you kind of have to do yourself. They do provide this kind of this handy explanation of what a CSP is. It's a HTTP header that allows site operators, so that's us as developers or site reliability engineers, site admins, fine-grained control over where resources on their site can be loaded from. And essentially what that means is I can tell the browser that, hey, if I tell you to load a font for me, I only want you to load this font from this location. And I'm going to have image tags on my site, and I only want you to load images if I've specified them in this particular location. And that's where this kind of fine-grained behavior comes in. So again, handily, Mozilla give us some examples of what a content security policy looks like. So, you know, being a software developer who obviously knows what he's doing, I just grab the top one, I throw it on my site. Netlify is really helpful in that you can kind of give it this underscore headers file right at the root of your project, and it's really straightforward to use. I just say, hey, on every single route, I want you to send this header back, this content security policy header, and the value that's going to be in there is default source HTTPS. So anything I'm going to load it over HTTPS. That's all I care about. So great, push it straight to master. It gets released, and my once awesome looking site now looks decidedly less awesome. So okay, pop open the console. Okay, right, we're getting somewhere. Refuse to execute inline script because it violates the following content security policy directive, blah, 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 blah. Okay, right, so fine, I've tried to do something that my content security policy is not allowing. So I do the natural thing, I jump on Stack Overflow, I start asking questions, I start Googling, and it turns out that Create React App, in an effort to be nice and friendly for you, actually inlines chunks of the scripts at runtime, essentially. And my content security policy is said that, hey, we don't allow inline scripting. So your site's tried to load something inline, and I'm not going to let you do it. That's dodgy. So luckily, Netlify allows you to specify environment variables, and the Create React App project will read this environment variable and say, oh, you don't want to inline runtime chunk, whatever. You don't want to stick stuff inline. That's fine. We won't do it. And you'll lose whatever it is, a quarter of a millisecond of performance. That's fine. I can live with that. So we set that to false, and happily, hey, my site's come back. Hopefully, now way more secure. So we go again. We run the scan, and okay, we're going in the right direction. C minus, that's pretty good. Score 45 out of 100. Okay, we've got a bit more points there, but we're still actually getting marked down on this content security policy. So why is that? Well, it says, okay, props. Yes, you've got a content security policy on your site. However, it's not very good because all you've said is that you just want to load stuff over HTTPS. So, fine, a bit more searching, and eventually come back to this. So, this is my super locked down, restrictive content security policy. By default, anything that I'm going to load, I'm going to provide it myself. So if I'm saying that I'm going to load a font, if I'm going to load scripts, anything like that, it's all going to come from me. You don't need to go off to some third party to go and get it. Object source, I think actually it's kind of recommended that you set it to none unless you have a specific need for some of those HTML elements. I believe they're all legacy elements, so most people nowadays, that's fine, you can probably set it. We run our scan again, and okay, we're up to a B. 75 out of 100. It's actually more than I got in any module in uni, so we're off to a flyer now. And even better than that, we've actually got +5 on our score. We're actually being given extra credit because our content security policy has not only been implemented, but we've managed to implement it without these kind of unsafe inline or unsafe eval directives that we could put in there to say, yes, we are going to do things inline or whatever. But we've managed to do it without them. So we get an extra 5 points. Happy days. See the recommendation at the top? It says, what's a good next step? Well, the use of the X-frame options header and content security policies frame ancestors directive are a simple and easy way to protect your site against clickjacking attacks. Okay, so naturally I go off, I read this, and the first thing I read essentially is, yeah, if you're not doing any kind of iframing, then you can just set it to deny any iframing on your site or of your site. So great, we're going to go and do that. But why am I talking about this content security policy? Well, remember this script that got injected, this malicious script? The bit really that killed us was the fact that they're scraping all this data and they're sending it off to this domain that we don't control. Well, if I've implemented a really strict content security policy, it takes that off the table. As soon as they try and connect to something that's not in my kind of whitelisted domains, that's it, it's dead in the water. It's not perfect, because fundamentally I still have this script on my site, but it can't talk to anything now. So we've killed that bit off. You will have noticed, yeah, that whole pain that I went through of pushing out to master, having this really secure site, and then it just broke everything. Yeah, that's quite common with content security policies. So some very clever people produce this as well. So the report-only version of the content security policy is doing the exact same thing that it would do normally, except you also specify a report endpoint. So if you've used anything kind of like Sentry or something like that, a lot of those kind of tools provide an endpoint that you can kind of fire to. And basically what that will do is those violations, so that error that you saw in the console, it will just package that up as JSON for us, send it off to there, and we can look at that report in our own time. It's not going to stop anything on our site, but we can still release it to production, and we can still kind of see, okay, if I was to go and make this kind of a set-in-stone policy, how much of my site's going to break. You know, I can kind of fine-tune it there with relative safety. So as I said, yes, this X-frame options, we're not doing any framing, we'll just deny it, run the scan again, and hey, A+. That's pretty good. Although, it's slightly odd because although we've got a score of 100 out of 100, we're only passing 10 of 11 tests. And in the recommendations, it says that you're only halfway finished, which is a bit backwards. Really what they're trying to get at here is that kind of web security is this evolving platform, and it's constantly changing, and you constantly need to be trying to keep yourself up to date with it. You can get extra credit, like we've done with our content security policy, which has bumped our score up, but it's one of those kind of situations where I think you're never really done. You kind of need to get to a point where you feel, whether that's if you're running kind of a personal site or whether you're running a kind of a massive e-commerce site, really you need to kind of figure out, okay, how much security are we comfortable putting in that's not, just taking the site offline. So in those list of test results, we kind of way down towards the bottom there, we would have seen this, the sub-resource integrity. And I've said that with the CSP, we've managed to stop that call out to that malicious third-party URL. This is the thing that actually stops that code even getting onto our site in the first place. So again, Mozilla, they give us this really handy definition. It says sub-resource integrity. It protects against JavaScript files and style sheets stored on CDNs from being maliciously modified. Perfect. That sounds exactly what we need to stop this getting on our site, right? We've tried to think back to the actual attack itself. The browser's landed on the site said, hey, go and grab this modernizer script for me. The browser will just go, yeah, fine, I'll grab it, I'll load it in, whatever, you've told me to do it, there it is. It doesn't care that this is in there, okay? But we do. We know what we should be getting when we go and get that minified JavaScript from our CDN. We know what the contents of that should look like, and that's what this sub-resource integrity is going to do for us. So in my index.html, I say, yeah, let's go and grab a version of Modernizer. There's a third-party CDN. I don't control it. Just go grab it from there. That's fine. And the browser will go. It'll do it. If I run my scan again, now you'll see we're getting this -5 score on the sub-resource integrity. So it's saying, yeah, look, you've not implemented it, but it's not worst case scenario. At the very least, you're loading it over HTTPS. So it's not awful. All right, so what is sub-resource integrity? in a very kind of the most straightforward way I can put it is you're just verifying that the integrity of that file hasn't been compromised. So what we're going to do is we're going to take a cryptographic hash of the contents of that file. So this is what my file should look like. I'm going to represent that in a hash with a hashing algorithm, and I'm going to put that in with my script tag on my site. But then what happens is the browser can come along and say, okay, yeah, you want me to go grab whatever we've got at the top there, jQuery 214 min, fine, I'll go grab that. And then when it comes back, it's going to go, okay, but you've also said that this is the integrity hash. So, okay, you've used the SHA-384 algorithm to generate the hash. So I'll look at the contents of that file, I'll run that algorithm against it, and I'm going to come back with a hash. And now I'm going to compare that hash to the one that you said that you expect to get. And if they don't match, I'm not going to give it to you. So, sounds like the sort of thing I want to do. I generate a hash. Kind of incidentally here, if you're using kind of third-party CDNs that you don't control, most of them will do this for you. If you try and grab a script from their site, they'll actually just give you this by default. Where you can fall down, like I mentioned before, BA were kind of hosting their own CDN. It's really straightforward to generate these hashes yourselves. You can do it as part of the kind of CI/CD pipeline whenever you're updating those scripts, and then all you need to do is make sure that the site itself is just grabbing the right version of it and has the right integrity in there. So great, we do that. We run our scan again, and now, happy days. We've got a tick, and we've got a +5. We're getting extra credit there. So it says sub-resource integrity is implemented, and all scripts are loaded securely. Okay, yeah, we're only loading one script, but technically, yes, all scripts are being loaded securely. I'm kind of happy with that. So what about British Airways? Yeah, it could be better. So I ran this scan earlier on today. They actually didn't get any points at all. They managed to pass kind of some tests, but I think the recommendation kind of says it all. You know, hey, great job. Your site is loaded over HTTPS. Well done. Yeah, when you get to the test scores, it actually gets a lot worse. For us, the worst thing was that our content security policy hadn't been implemented. For them, it's actually even worse. They have session cookies that are set insecurely. So either they haven't set it with the secure flag, or they're setting it over HTTP. Why is that bad? Well, if you've got a session cookie that you're setting over HTTP and you're communicating over Wi-Fi, it's super easy for me to just sit somewhere, sniff those packets out of the air, grab that cookie and stick it on my browser, and now I'm you. I can get myself a flight to anywhere in the world. So as we kind of close up here, there's a couple of tips that I kind of want to leave you with. I really want to try and give British Airways kind of the benefit of the doubt as best I can. It's been hard going through all the research involved in kind of looking up all this kind of stuff, but I think the quick win there is just you don't need 30 scripts on your booking page. You know, people know what to do on a booking page. You don't need third-party advertisements. You know, you don't need a live chat system. People know what they're doing there. They don't need a lot of direction. You don't really need to track people there either. Just reduce the threat. Like, you have thousands of lines of code there that really don't need to be there. So why have them? All it's doing is it's dead weight. It's slowing up the response times, and it's places that attackers can hide in. The second part here then is to kind of ask yourself, where am I vulnerable? If British Airways, when they went through that whole situation of, I can imagine the conversation going, when they pitched this idea of, hey, we're going to make this mobile app and we're going to make it really performant in some places, but we're also going to get this really great kind of quick win by just proxying the site for the rest of it. I imagine that probably went down really well, but it would have been helpful for someone to say, actually, is that really what we want? Do we want all of our customers bottlenecking to this one place where if we get breached there, everyone gets affected by it? And using tools kind of like Mozilla Observatory, like we've kind of shown, there's a whole host of kind of scanning tools out there, kind of free and paid for ones. The paid for ones, most of them come with a free trial, so just try it and see. It's really not hard to do to just see how well your site is performing. Kind of just general housekeeping stuff, keeping things up to date, that's so important. If you go and talk to kind of anyone from sort of the kind of cloud native side of things, especially kind of the DevOps side of things, one of the kind of the best wins that you get there is that if you can get a really fast kind of release cycle, it actually mitigates so many of the problems that you face in security. Things like containerization, and I know we're kind of getting away from JavaScripty stuff here, but just keeping things like that up to date, keeping your operating systems up to date, goes a long way to just getting rid of so many of those problems. Like I mentioned at the beginning, I don't have security in my job title. If you're working on something that has real world implications, I would strongly recommend you speak to someone who kind of knows what they're doing. It's all well and good kind of going and testing this stuff for yourself, and you will get a whole host of learning from doing that. But yeah, I would recommend if you are dealing with real customers' data, that's something that you need to kind of go off and make a point to try and do. And finally, as we mentioned before, learn from others' mistakes. I would have hated to have worked for BA's engineering department during this whole saga. That would have sucked. That would have really sucked. It's much more fun being on this side of it, where you can kind of look and have a little bit of a laugh and a giggle, and get some good learnings from it. And I would rather that, as developers, we try and stay on that side of the fence as best we can. A couple of things to check out then before I leave. So as I mentioned, that's the kind of the Mozilla Observatory tool. The kind of generating hashes for your scripts, if you're kind of loading them via a CDN, there's a site where you can go to that will literally just do it for you. There's a couple of blogs in here. I'm going to get in trouble because I'm calling out Auto Trader and I work for a car finance company. But they actually wrote a blog about kind of how they went from not having a content security policy to having one. And it's a really cool kind of step-by-step look. These are the pain points that we went through. These are the things we struggled with, and these are the things we learned going through that process. And finally, Darknet Diaries podcast. If you found any of this interesting, I would strongly recommend you go and check it out. I think Callum, you turned me onto it like middle of last year. I'm an avid listener now, and actually this a great deal of this talk kind of came from that episode there, 52, about MageCart. Yeah, I'd strongly recommend you go give that a listen. Really, really cool. And with that, thank you very much for having me.